Good morning. Welcome to the second session of DBA Fundamentals for the month, maybe third. We might have already had the one in Down Under, but today we have Thomas LeBlanc doing Execution Plans for Beginners 101. I added the 101 in, but anyway, it's a perfect session for us. But first, let me get to a little housekeeping first. Let's see. We have a new sponsor, in addition to the one we still have with Century One, but we have a new sponsor, DB Watch. They're an enterprise manager across multi-platforms, and obviously they're trying to get some inroads into Microsoft SQL Server. One of the things you can do to help us is, if you can, go to dbwatch.com. And they make it very easy to download a trial. I've already downloaded a trial because if I sponsor or somebody sponsors us, I want to at least know something about their product. And I haven't implemented it yet, but they'll send you a quick code for 30-day trial. And I'm going to try it on some of our sandbox servers and a few other development servers and just check it out. If you can, go to dbwatch.com, and I guess this sounds quirky, but tell them the DBA Fundamentals sent you. Century One is our longtime standby sponsor. They have, it's easy to go to their website, and they have tons of different things that are free that you can deal with. Thomas is going to be going over execution plans today. There's a great product on Century One site that kind of makes things a little bit easier to work with on execution plans, called Plan Explorer. Download a free copy of that. It's always free. It's the professional version. It's very nice to use. You might want to try that in addition to Microsoft's version. Let me back up. Sorry. We have our contest going on this year. Everybody that attends a session is put in. For every time you attend a session, you get one entry, and you have to be a member of PASS. Most of you are, but if you're not, you can join. You must follow us on Twitter at DBA Fund, and you must be subscribed to our YouTube site at dbafundtube.org. The YouTube site's really getting a good collection of videos, so you might want to go check it out. And there's always contests and things going on. This is what we use to help give away sessions later on in the year. And we've sort of averaged like 2 and 3 sessions a year that we get to give away. We have discount codes. And this is the discount code we want you to use. If you register with our discount code, we put you into a pool of people that we draw out one at the end of September, and we give you a $500 Amazon gift card. So you in addition to saving $150, you have the possibility, and we usually have about 50 or 60 uses. So the odds are pretty good that you could win. So use this discount code. If you don't care, you might want to kind of highlight this page. On the top right hand side of your screen, you can hit the camera, and it will put a copy of this to your desktop or wherever you want to store it. And when you sign up for PASS, use our code. There's a 24 hours of PASS coming up this week. It's a cross-platform. It's got a lot of different things. There's a lot of speakers that are available with this that are excellent speakers with great topics. Go check it out. That's the if you want to copy that down, or if you want to go back through our slides, we'll have these up. They will be recorded, and we'll have these up in a couple of days. You can go back and sign up. And 24 hours of PASS is sort of a preview to PASS Summit, and they have different topics now. So go check that out. I signed up for 2 or 3 of them. Here's some of our sessions coming up. On May the 8th, we have advanced indexing for beginners, and obviously I have this a little out of order. May the 1st, we have Kendra Little with Index Design Patterns for Beginners. And I don't have it listed, and I should have listed it, but we have a Linux session coming up that I'd love for you to sign up for. Here's some other virtual group webinars coming up. Professional development is starting back up again, so support it if you can. Getting and nailing your interviews will be on April the 27th. Let's see, cloud. Some of our favorite chapters are Saturday Night SQL and Women in Technology. They'll be having a session on Saturday night, if that's a time you can do it. Azure Machine Learning Studio, 4 tips from the pros. And then there's our session. And there's lots of different groups for pretty well every major language and every topic, so go check that out. SQL Saturdays are freebie versions of past summits, usually in your area. It's a great thing if you can find some. I usually find about 2 or 3. Nashville has one. I usually go to Louisville and to Chattanooga. Sometimes I get down to Atlanta, but they're speakers that are speaking at a local university or site close to you. It's free. You go and learn a lot. You meet a lot of people in your area. Usually cost only the price of lunch. Go to SQLSaturday.com and you can find out the closest one to you. Connect with PASS. You can go to pass.org and get your free membership and get access to all of this information. And as I said, we will be recording this, and they'll be at dbafund.org or dbafundtube.org, usually within a couple of days. Today, as I said before, we have Thomas LeBlanc doing execution plans for beginners. I'm going to let him do the introduction on the topic, but Thomas is an MVP and has been around for a long time in the SQL environment with PASS, so he knows a lot about this stuff. He's more of a BI developer, but he does a lot of DBA stuff every day. He's a data warehouse architect in Baton Rouge, and it doesn't say this company here, but anyway, I'm going to turn it over to Thomas and let him take it away. Let me make you presenter.
All right. Clean screen. Can y'all see it?
There we go. I see it now.
Wonderful. Thanks, Steve. Yes, my name is Thomas LeBlanc, and I am a data warehouse architect. A little bit more about me. I just made MVP in October of last year. I do mainly data warehouse work, but every day I have to do something in the DBA world. When I was a developer and maybe a DBA developer, they used to say I was a database normalization nut. Today, I think I'm just a little crazy about dimensional modeling. And I like to consider myself a retired developer. So probably 10, 15 years ago, I got out of the development world and went into the data world, and I haven't regretted any of it. If you want to find me on Twitter, Gmail, or blog, you can just search for TheSmilingDBA. I don't have a picture of me smiling, but usually I'm pretty happy looking guy. And yes, I have volunteered in the PASS world for quite a while now. I was a virtual chapter chair of the Data Architect VC, as well as the Excel BI, and I was on the nomination committee for the board of PASS in 2016 and 2017. So my assumptions about y'all is that y'all write T-SQL, either have limited or not used execution plans at all, either developer, DBA, or just a cool IT dude. You know, you do everything. And hopefully you have a little sense of humor as we go through this. So what are we going to talk about today is pretty much 4 things. We're going to look at the terminology that I've heard in the past 10 years about execution plans or query plans. We're going to look at a brief history of the changes in query plans over time with SQL Server Management Studio, and hopefully we'll just do demo, so you can get a taste of all of this. We'll also look at some new features on there that's in SQL Server Management Studio. Steve, I think you're still mic
Oh,
might
I'm
still be on. There you go. Thank you. All right, so no more background noise. Uh, all right, so let's look at the history of SQL Server Management Studio. And if you're as old as me, you might remember something called Enterprise Manager, and it was actually your queries were in something called Query Analyzer. Well, don't fret if you want to go back to the past. There's actually a set command, show plan text, that'll actually show you what execution plans used to look like before you had them graphical, which came in SQL Server 2005. And I'm using the SQL Server terms, but now today you really look at SQL Server Management Studio, not necessarily what version of SQL Server you're on. But in 2005, graphical plans came out. That was the big one I remember. In 2008, you had a missing index feature. 2012 were the warnings, and then you could see the memory grant for your query, which was a big deal at that point in time, especially if you're still on 2008 or R2, which some people are still on today. In 2014, they added the operator cost in addition to the IO and CPU cost. And in 2016, where the big deals was this query store where you're able to compare plans. And there was even something called live query statistics, which we'll look at as well. And in 2017, everything's been improved. One of the neat things is the IO statistics are shown in the properties. So let's go ahead and look at a demo of the history. And I'm going to switch over to my SQL Server Management Studio. And I'm running the latest Management Studio. I think it's all the way up to 17.6 now. Yeah, 17.6. I just updated it the other day just to get rid of that message that I need to update it. So the first thing I'm going to do is I'm just going to clear out all the indexes that possibly could affect any of these demos that I've run over and over. And next I'm going to just go ahead and jump into using the AdventureWorks database. I just shorten the name so it's a little easier to type. And I'm going to just set a command called show plan text on. And after I do that, I'm going to run a query. Now what that does, it actually puts the query plan, just like a display estimated plan. It'll show me the syntax of my query, and it also shows me the text plan. Now back in the day, you would just look at this as a text output rather than in a grid, and this is what you would get. You get this little table scan object database schema dot object name. In this case, it's doing a table scan on the table database log. So there's no clustered index on this table. And that's how you actually had to read the plans. Now, that one's a little bit easier, but say, for instance, that, let me shut down my email here. Might be a good idea. Say, for instance, you had something a little more complicated, like subtotal is less than 100. You get a little bit more here. So what you'll notice is things are indented. Just like when we look at a estimated plan, you kind of have a flow of what's going on inside of here. So here at the bottom is the clustered index scan with 2 compute scalars. You see the compute scalar on this one happens to be total due, which is a computed column, and then the filter that brings the data back to your screen. So this is how you actually had to look at query plans with a little more data than this, but it just gives you an idea of where execution plans started and where they are today. So I'm going to set that off. I'm going to get my grid back on, and now I'm just going to highlight a query, right click, and go display estimated execution plan. So when I do a display of an estimated, I'm not actually running the query, I'm just running the part of SQL Server that provides the plan to me. And as I zoom in it, you can kind of see something similar to what we had in the text plan. If we read from right to left, we see that we do a clustered index scan, and it costs 99%. Then it does 2 compute scalars of 0%, a top, which is our top 100, and then eventually to the select. And if we hover over the select, we'll see the actual estimated cost. So the subtree cost, and this is the final subtree, is 0.005. Now, at that little window popping up kind of irritates you in some way, you can always just click on that, and actually you can right click and go to properties. Now my properties window to my right, and I can actually look at each iterator in the plan and see the different properties from it. So I can see the defined values of the select, I can see the object that I'm querying, as well as the object list, and even scroll down further for more information. Some of these I don't have drill through is like the estimated number of rows, what was actually the estimated number of rows that would be read, which is pretty much the whole entire table. So that's a displayed execution plan. So next what I'm going to do is I'm actually include the execution plan and look and run at the messages. So I'm going to highlight it, right click, and I'm going to say include actual execution plan. When I run that, now not only do I get a plan, but I get the text result in the grid, and then here's my execution plan. So estimated is what the query optimizer estimates would be the best plan, but sometimes the actual plan can be different. So we have this top, we see here a cost is about 0.05, but what I'm going to do next is I'm going to actually look at both a top 100 and a select star. Now when I run those two, I get both of the query results. It's still executing the query, so I want to wait for it to finish before I click on the execution plans. Now you can see that the top 100 is actually only 1% of the total. So when I run more than one plan, I get the percent that each one costs relative to running all the queries in the batch. So I can see my top is 1%, but my bottom one, which is select star from the whole table, and of course you should never do a select star. It's a bad example if you're a normalization person like me. But what I want to show you is that on the far right of each one of these plans is the clustered index scan, and both of them cost 99%. The difference, though, is that top is actually coming down the pipes, and you'll see estimated 100, estimated 100, estimated actual 100. So the top actually sends down to that clustered index scan to only bring back 100 rows. It doesn't wait till it gets to the top iterator to bring them back. It actually sends it down even though you read plans from right to left. If I go down to the second one, which is selecting all the rows, then you can see we actually have over 31,000 rows. Now to see that, what was added was something called set statistics IO on. So if I run this set command and then run those two queries again, and I go to messages, I'm going to see something different. I can see a scan of one, which is my clustered index scan, and how many logical reads. So the top had 7 logical reads, but the one that selected all still had 1 scan, but then it also had 689 logical reads. So that set statistics IO on can kind of help you understand why one query plan might be less expensive than the other. In this case, the IO is less expensive. Now, a new thing they've added in Management Studio is they've actually put these into the properties. So here, if I click on that index scan, I can see that actual logical reads. And then if I go to the other plan, I can see that 689. So SQL Server, Microsoft has improved the query plans over and over by adding things like this for us. So anytime you get upset at Microsoft, just wait for the next version and it'll get better. Trust me. So another one you have is what's called set statistics IO on, and I'm gonna turn that on, but I'm also gonna free the procedure cache and drop clean buffers. Now you would never do this in a production system. This is my dev machine, so I'm doing it in a dev machine, not necessarily a production machine, but I'm actually flushing the cache so I can get another read on this. So I'm gonna launch that top 100 and I'm gonna go to messages. Now that IO time now gives me how many milliseconds it took me to parse the query. Then it also gives me an execution time in CPU time and an elapsed time. So my CPU is, it took 15 milliseconds for the CPU to run this, but in reality, it took 16 milliseconds overall. It's a little bit different because other things are happening other than just CPU. Well, what you'll see here in this IO statistics now is not only do we have the logical reads, but we also have physical reads and read aheads. Now what happened was logical reads means SQL Server is reading stuff logically from memory. And it has to do that with any sort of data. It never can go from disk to your client machine. It has to go in memory first. But what that entailed was 2 physical reads, and then something that SQL Server does is it reads ahead. So SQL Server has intelligence in it that helps it read ahead in the system to grab data that it might think it needs. And we get that plan again, and we can see the same information that we saw earlier with the IO statistics. But this time, not only do we have the logical reads, but we have physical and read aheads, which is pretty neat. So let me clean those buffers again. Again, you wouldn't do that on a normal system. And here I'm running that top 100, which does the read aheads for me. And what you'll notice in the select star is even though it did the logical read aheads, that previous select top 100 has already cached in the data cache. So my full load, not the top 100, can go just to memory. So that's how you can tell if things are in memory or if it's having to read something from disk in order to get it in memory. So that statistics IO is really nice. I'm gonna go ahead and clean that out again. And we're going to do two more things before we move on, really 3. There's something called show plan all. And if I launch that and then run a query, I'll see that I get the execution plan in a table. So you remember that indentation? Now I see it actually in a table. So that's plan all. I'm going to do the Control T for text, run it again, and you can see that in text. And I'm going to turn that off. And this is just for historical purposes, just so you can see what used to be around. There's also one called statistics profile on. And I'm going to go ahead and run that query. And I'm going to put it to, instead of to text, I'm going to do it to grid. And the profile, statistics profile on, I get the results of the query with another table of the execution plan. The last one, and I'm going to have to turn off the actual plan first, is one called Set Statistics XML on. So I'm going to run that and then run that same query. And what you'll notice, you'll get the results, but you also get a hyperlink to the XML. So if I click on that, it actually brings the query plan into another window. And what that is if I right click and I say show execution plan XML, it's basically the XML behind the query plan. So whenever you get a query plan or execution plan, it's actually an XML file. So that's what Steve was mentioning earlier, was that there's been third-party companies that have written some really neat tools. So he was talking about SQL Sentry's Plan Explorer. So I can actually move this XML into Plan Explorer. I have another one for Apex that has one similar to it, but SQL Server Sentry was one of the first ones to do it. And actually take that plan and actually launch it inside of their application, which is a really cool thing to be able to do. They've done a little bit more to improve what you can see in a plan and kind of sort it out for you. So let's see if that pops up. Which I don't see it popping up, but that's okay. That's what Steve was talking about earlier. Some third-party tools have been written, and they're free, so don't be afraid to go download them and use them. So let's go back to our slides, and that's a little bit of the history of it. So let's move on to some terminology. I'm calling them execution plans, but some people call them query plans. The query plan is used by the optimizer in order to return data to your client machine. Now, there's many optimizer articles. One that I like was from Gail Shaw. It's on SQLServerCentral.com. You might want to go read that. I think it was a 4-part series. We looked at the displaying of the estimate and then the actual plan. Sometimes they're different, but most times they are the same. Now there's a thing called live query statistics. So what is a scan? Well, we get a table scan when there's no clustered index on the table, and the table is considered a heap. The clustered index scan means that it's not a table scan because there is that one clustered index on the table. A non-clustered index scan, and all 3 of these are scans, is when it's able to scan a separate index other than the clustered or the table. Now, you might see something called a seek, and when you get a seek, it's a good use of an index. So we'll get a seek, and we might get a nested loop or not to look up more data. But if we do seek data and more data is needed to be extracted to the client, you end up with a lookup. There's two kinds of lookups. One's a key lookup and one's an RID lookup. The key lookup means the table has a clustered index. The RID lookup means there is no clustered index and the table is considered a heap. So let's go back to the demos and we're going to look at some of these scans as well as some seeks. So the first thing I'm going to do is clear my database up, make sure I don't have any of those indexes I don't want on the tables. And then we're going to look at a table called database log and the columns here. So I did a little better job at not putting select star and actually specifying the columns. I'm going to display an execution plan for this, an estimated plan, and you'll see because this table has no clustered index, we get a table scan. It's going to scan 100% of it, and if you hover over the select, you can see the estimated subtree cost is 0.442822. So what I'm going to do is I'm actually include the execution plan now, and I'm going to run a similar query, but I'm going to put a where clause in it. So I figured that the cost should go down because I'm doing a where clause. I only get 11 rows instead of the over 1,000, but if I look at the plan, I actually have the same cost. SQL Server, because there's no index, has no smarter way to get the data or sort it. It's going to go through the table scan, and what it's going to eventually do is do something called a predicate lookup. The predicate lookup means it's just going to go through the whole database or all the data returned and apply the filter. You can see it did some parameterization by the @1 variable being add, but basically it had to do the exact same thing because there was no type of index it could use. So what I'm going to do here is I'm going to alter the table. I'm going to add a constraint and give it a name, and I'm going to make it the primary key. Database log ID is the column that is unique throughout this table. So I executed the alter. I'm going to go back to that select and look at the execution plan. And even though now it's doing a clustered index scan, the cost is still the same, 0.44. So basically that clustered index just organized the table from a heap into a structure index. So now I'm going to go do that second one where I have the where clause. And what I'll see here is that same index scan. Now what it does do is it applies that predicate, which brings out less actual number of rows, but the cost is still 4.4. So the actual cost is still the same, but the actual reads have gone down because you have a where clause. So the total cost is the same, but not necessarily the time or the use of IO in this case. Now, what I'm going to do now is I'm going to add a non-clustered index. So our primary key was the clustered, and now I'm going to add an index with 3 columns. It's database user, schema, and object. And now any query that has a where or join on the database user is the first one, it's going to actually reduce the cost. So here I'm going to run 2 queries where the database user is either DBO or SIS. Run these 2, bring it up a little bit higher, and I could see that 100% of both of these is on that index seek, which is the new index we created. And if I hover over the select, I can see I drop my cost from 0.44 to 0.01. So that non-clustered index has now reduced the cost of this. What's interesting though, even though both of these costs are the same, but they return, one returns 1,591 rows, the other one returns 11, you'll see that the reads are different. So 19 logical reads for the 1,500 rows, and then 1 scan, but only 3 logical reads for the other one. So it actually does do less work, even though the cost appears to be the same. That's what's good about having that IO with you. And just to show you what we're talking about is if I do a group by database user, you can see that DBO user has 1,591 and SIS has 11. So let's do something like a like, and let's see what happens. So instead of saying equals, we do a like. Now here it did the index scan. So before we had the index seek because we had that where clause, but once we do something like a like, it can't actually, especially if the percent sign is at the beginning. Now if we take that and add it to the end, it'll actually change because the SIS is at the beginning. It'll do a seek and do a scan from there. But I just want to show you the difference between an index seek and now an index scan. And I think I got one more example of that where I just select the 3 columns and it actually scans it. So here there's no where clause, and yet the cost is going to be 0.01. So we just selected those 3 columns and we actually was able to reduce the cost because it did a scan of the non-clustered index rather than the actual clustered index, which is what we saw previously. So here's one where we just look at those 3 columns in the non-clustered index, but here's a second one where we add database log ID. And the reason I want to show this is because even though the index itself does not have the database log ID specified in it, so if we go back up to our create of the index, you do not see the database log ID here. Since it is the clustered index, database log ID is our clustered index. That was what that alter add primary key. The clustered index, whatever fields you provide here, are actually included in all non-clustered indexes. So if I click on the index seek here, I can see in my output list towards the bottom, I'll just come up here. It's easier to get it here. I see that the columns that my output is actually looking at, schema and object. If I go down to the one on the bottom with the database log, I'll see that I have in addition to it that log ID, object, schema, database log ID. Actually, I couldn't see that there. A little bit clearer for you. So there's that database log ID, and because it's in my non-clustered index, I don't have to go find any additional columns in a lookup. But we're going to see a lookup in just a second. So let me go back down to where I was at. I'm going to clean my cache again. And I'm going to say, let's add, instead of just having that object and schema with the user ID, we're going to add additional columns. I'll launch that, go to the execution plan, and you can see I have the index seek, which is on the object that the non-clustered index I created, and then it brings back, you can see the little line, it brings back an actual number 11 rows, and now it's got a loop through a key lookup to actually find that additional data in the clustered index. So here it actually had to go down. If we look at the object list, it had to go find post time and event from the clustered index. So this is an example of a seek with a key lookup. Let's go back down. Now what I want to do is I want to create what's called a covering index so I don't have to do that lookup. So I'm going to create a new non-clustered index on that table. Database user is the only column index, and then we have something called an include. So now these columns are only going to be included in the data pages of the index and not the B-tree structure of the index. So I created that. I'm going to launch that same query, and now the seek of the non-clustered index covers all the columns in my select, and I don't need a lookup. So I've actually improved the performance. And if you notice here now, our actual cost is 0.003. So as we create these indexes, we notice that queries become faster and faster and faster. So is that the last one? Yep, that's the last one in this set. Let's go back to the slides. All right, so this was seek, scans, and a couple more things that we looked at. And now let's go ahead and look at some more terminology. Loops, there's three kind of loops that you'll see most often. The first is a nested, and what that basically is each row in the outer is joined with the rows from the inner of the join. If you actually put your cursor over the iterator in the plan, it'll actually show you that description. So it's not like I made that up. I actually copied it from their description. The other one is called a merge join. It's kind of like a zipper. Things in the outer and inner rows are sorted in the same order, so you can just go through it sequentially and merge them together. And what's really nice is once it's merged together, you can actually pass some of that data off to the next iterator. It's mainly it's because the two input inner and outer iterators are sorted in the same order. A hash match or join is a little more complicated. Can't tell you that I understand it all, but it's not bad, but it is the most expensive. Your join columns are hashed. The data from the hash table is put kind of in 4 buckets, and then you have this probing of the hash and the additional data to find and join the two sets together. So let's go back to our execution plans, management studio, and we're going to look at the loops. So I'm going to turn on my include actual plan, get in my database, set my statistics IO on, and the first one we're going to look at is a nested loop. We're basically joining the customer table with the sales order header table by customer ID, and we're only looking at one customer ID. So I'm going to go ahead and launch that, go to my execution plan, and you'll see that that one customer, 11091, is the actual outer row. It's going to go to the loop, and it's going to go find 28 rows. Let's see if I can hover over it again. There you go. Estimated and actual number of rows are 28. So it goes from the clustered index of the customer table to a non-clustered index seek in the sales order table, returns loops and joins those together. And then that pipe will bring those 28 rows of the two different data sets to our select. Now let's do this. Let's add 2 columns, sales order header account number and order date. Same query except 2 additional columns. So the first one we saw was actually 2 iterators that were in 2 different objects, but now we have that same seek of the clustered index by that customer ID looped to join additional data where it does a seek of the non-clustered index for customer ID, but it brings back those 28 rows, which that non-cluster does not have the account number or order date. It does another nested loop for a key lookup, which brings in the rest of the data, which we see in those output lists of order date and account number. So here's 2 different nested loops from 2 separate tables and one within one particular table. Pretty neat stuff. All right, so now let's do this. I'm going to make sure that that index is not on there, and I'm actually create a covering index for that query. So now I've added a non-clustered index to my sales order table, and now I do not have to go to a key lookup to find the additional date. The include column now has those, and I can go into an output list. What's really nice is my order ID, customer date, and account numbers here. And you don't see really that customer ID lookup, but you see the seek predicate here. Before we had a predicate. Predicate is when the where clause or the join doesn't have something it could seek on, and usually you see a scan. But in this case, we actually have a seek predicate, which is good. Can't get rid of that little display there. Let me click on that, and you can see that that customer ID is a seek predicate. Seek predicates are good, so when you see it, you're in good shape. All right, I'm going to drop that just in case it messes up any other demo. And now we're going to look at a merge join. So basically what I'm doing is joining product table with product inventory. I'm going to do a sum of the quantity from the inventory, and I'm grouping by the product name. A typical, analytics type query where I group product and find the total quantity sold. Now, if I look at my execution plan, I could see that I did an index scanned on the inventory. The stream aggregate is doing the sum and the group by for me. Then it's going to merge that with a scan of the product, and basically it's bringing every one of those products in because I need the product name in my output, and that's what it's given me is that product name, and eventually that's what I want to group by to get that sum total. So that's a merge, but let's do one more step. Let's add location ID from the inventory table. Typical things your user wants now it grouped by location ID, not only product, and have it broken down a little more. And what's really changed here is that our aggregate has been moved out of before the merge join, and a sort operator or iterator has been added. Now, sorts are not the best. You can see that it costs 47% of the total plan. So be aware when you see a sort, it might be a better way to do your query, or you might have to look at different indexing methods. But basically, our stream aggregate got moved out by including one more thing in our group by. All right, so that's an example of merge. Now we'll do a hash. So basically, this is in my great estimation, a very over-normalized database. You have to go from human resources employee joined with business entity to get the business entity address, and then the actual address, as well as joining to a person table by this business entity ID. And what we're doing here is we're putting together last name and first name, and then looking at the title and city of these employees. So basically what happened is this upper part, as I zoom in, this upper part of first this nested loop putting together about 290 rows comes across, and it's going to need additional information from address. But if you notice, the number of rows is going to be about 19,000. So it got to a point where a nested loop would have been too expensive to bring this data together. So it did a hash. If you just highlight over the hash, you see the description. Use each row from the top input to build a hash table, and each row from the bottom input to probe into the hash table the outputting of all matching rows. So that's your hash, and you can see as you get more and more complicated queries, here's one that doesn't do a hash, where I just say product ID equals one product, 870. So I get a nice nested loop, even though there's 12,000 rows returned here. Really, it just looked at one, so it just had one to go down in. But let's say I add something like an in clause, like in two different product IDs. Now, those two product IDs are not sequential, so what happens is, even though you get in two rows, and about the same amount of number of rows, what estimated 18,000, and it actually got 121,000. It needed a hash to do those too. So just by adding an in clause, sometimes it can really drive up the cost. And also, if I just say or, which some people say that'll help it run better, I still get the same plan. I still get that hash mash. And here, you know, we've talked about this earlier in the history, but there's that missing index feature. So it actually says, hey, I can impact your query 85% if you add this index. And I could basically right click and go to missing index details and actually see if it's a good enough index to add to here. I'm not going to do that. I'm going to go back out, and I'm actually put two sequential numbers in my product ID here. And then you see that since it's sequential, it actually could eliminate the hash. So it's really interesting, and it really depends on the amount of rows that comes back out at you, which this one doesn't have a lot, that determines how this is. So it has a lot to do with the statistics of the distribution of data in your table and index on if it uses a hash or a nested loop. And if you notice on the bottom here, I was putting this option recompile. I wanted to make sure I got a brand new plan each time this was placed in there. So this is just a way to not use the cached execution plan, which we'll look at a little bit later with the query store, where some cache plans go. All right, so that was the demo of the loops. We saw a compute scalar. That's sometimes you'll see for concatenation of the last name and first name. We saw a sort iterator, and usually that happens with order by, distinct, or group by. And then we also saw an aggregate stream, which actually is the group by or count sum, etc. Use some sort of window function that might be used. We saw the properties, which gives you more information. And then a lot of people always say, well, you're adding a lot of index. That really affect the insert updates. And if you do deletes, delete. So, you know, you don't know until you actually take a look at it. So let's look at a demo of that stuff as well. So the first thing I'll do is just show you that scalar again. I'm going to put on my actual plan. Always look at that IO and time. It seems to be in everything. I don't know how many people use CTEs, but here I'm doing a CTE to get all that employee data together, and then I'm joining it with the person. So this was kind of like a rewrite of that previous one, and I'm doing an order by. So let me launch that, and you'll see that compute scalar. This is the compute scalar that's going to get this defined value in your properties, and it shows the concatenation of last name and first name. So when you see that compute scalar, that's usually the reason for that. Let's go to the next one, and we'll do just a simple sort. And you'll see that our sort, we did a simple order by shelf. The clustered index scan is not by that column. So what it has to do is it has to do a sort. And really, it's kind of a blocking because it's taking all the data and it's got to sort it all before it can pass to the next iterator. So if you ever heard the term blocking iterator, this is one because it has to complete before it could send anything else down that pipe. The last one we'll look at is that stream aggregate, which we've seen earlier. To show you another example, here's where it actually does the grouping and the computation of that sum value or count. What are we doing? We're doing a count. We're doing a count here and a sum. So that's our stream aggregate. Now let's go to an insert update. And basically what I'm going to do is just get rid of all those indexes we created earlier, set our statistics IO on, and we'll turn on the plan. And I'll just run a simple insert into database log, and I can see my plan has a cost of 0.1. And there's really nothing here. There's a constant scan, some compute scalars for the data, and then just a table insert. Now let's go ahead and add back the primary key and those 3 non-clustered indexes that we had earlier. And now let's do an insert. I forgot to show you too, but the logical reads I think was 2 in the one before. So now we got 14 logical reads because now it has to do more work with the indexes, and our execution plan cost a little bit more. It went from 0.01 to 0.04. So it's 4 times more expensive. And you might say, oh, I don't want to put something on that's 4 times more expensive. Well, you got to measure it versus the return of the data versus your insert. So be cautious with adding a lot of indexes, but know that in reality, sometimes inserts updates need to take the hit in order to get the return data. Same thing with an update. So I'm trying to just do an update here. Look at that, 218 logical reads, and the execution plan is 0.06. So it's got to do a lot more work. But what you see on the end is an index seek. So the update in that where database user equals sys actually can seek out the data first before it does the update, which actually reduces the cost because there's an index on it. I'm not going to keep those changes, and I'm going to roll back there, and we're going to go back to our slides. Now, a big deal for a lot of people is this parallelism and cost above threshold. So if you have multiple processors, which most people do unless someone's giving you a VM with only one processor, you actually have multiple threads that perform the work for you. In the configuration of a SQL Server instance, you have a max stop configuration. It's set by default to 0. You also have a cost threshold for parallelism, which defaults to 5. So we've only looked at costs for like 0.44, 0.1 so far. But this, if my cost gets above that threshold, 5, then it's going to try to use as many processors as are available. In this example, 2, because I set it, but usually it's default by 0, which means unlimited. that'll use it to actually, if you want to reduce parallelism, you bring that cost up. If you want to increase parallelism, you bring the cost down. And we're going to look at an example of this. So I'm going to close this window, and I'm going to go to my object, and I'm going to my instance and advance, and I can see my threshold is 5 and my degrees of parallelism is 2. I'm going to keep that for now. I'm going to go to my parallelism query. I'm going to include actual plan. Nice little CTE we got here. It's joining a lot of stuff from the sales and then ranking it by amount. Typical kind of Windows function you see people doing. I have comment out option max stop 1 because what I want to see first is I want to see the parallelism. So you see here that parallel is actually an iterator where it gathers a stream, but where it starts is all the way on the right bottom. So let's look at this and let's zoom in a little here. So here's our clustered index scan, and if I click on it and go to properties, in the actual number of rows, I can see each thread and how many rows it's handling. So because that max stop was 2, it got 2 threads, ran in parallel, divided that data up between the 2 threads, and then sends it across the iterators. And you can see that double arrow line in the little circle, and it comes all the way across and ends where it gathers the streams together, puts them together, and then sends it to the end. Now, if I go to the very end and hover over the select, I can see my cost is 4.6. You might say, well, why is it running parallel? Your threshold was 5. Well, let's see why. So if I go down here and I force it to be 1, meaning 1 thread, if I go to the plan and I hover over it, I see my estimated cost tree is 6.5. So by running in parallel 2 threads, it went from 6.5 to 4.6. Now let's do this. Let's go up to the instance. A really good example of how this works. I'm going to change my threshold to 5. Go back to my query, comment out the max stop 1, run this. Go to my plan, you don't see the parallel, you don't see it at the end either, and the cost is at 6.5. Now let's go back, change it back to 5, and also what I'm going to do is change max degree to 4. So instead of 2, now I'm going to do 4 threads. Remember the other one was, I think, 4.6. Now, if I hover over it, it's gone down to 2.9. So you might ask, well, let's use all the processors possible. Well, sometimes you want to be cautious with that because you don't want to hog the processors. Someone could run a query that runs a half an hour. If it's multi-threaded and it uses all 8 processors that you have, it might block other systems to run. A good one that you want to use most of your processors on is any maintenance routines. So index rebuilds, backups, update statistics, any of those that run in parallel, you still might want to run with a higher max stop. There's a lot of things in SQL Server that's improved that over time. It's really an advanced topic, so I'm not going to jump too far into it, but this is a good example of the max stop feature. So let's go back to the slides. Here's some really bad ones that I found running max stop. You can see that one to the far right is a table scan, and I think it had like 68 million rows. Just by adding a clustered index to that fact table, this thing went from like running 4 hours to like 10 minutes. So, be cautious on not putting clustered indexes. The biggest thing I see a lot is people design stuff and start using it saying, oh, no one's ever going to use this. And then all of a sudden it becomes this big, huge data warehouse and 100 million rows are in it. And no one's ever created a clustered index. There's 4 non-clustered indexes, but no one created a clustered because they thought it didn't need it at the time. Well, good database design in the front part can solve a lot of problems. So that's a lot of the introduction stuff. What I want to show you now is a little more intermediate level, but it's really something you should start looking at if you have SQL Server 2016 or 2017. First one's called the query store. It stores plans in a DB and it has to be turned on. So all those execution plans, even though they're stored in the instance, you can actually have them stored within a database now. And what it's given you is an additional dashboard reports. The first 4 regress queries, top consumers, high variation, and overall resource consumption are in 2016, and they added track queries and queries force plan in 2017. Now, we're going to look at both the query store and the live query statistics for this next demo. So I've got a database where this is turned on. I'm going to right click on it and go to properties. And you'll notice in 2016, 2017, you have an additional item here called Query Store. The operation mode is read-write. There's actually just a read only. If you ever fill up this max amount of space and don't have the purge running, there's a cleanup that has to be run in order to keep it clean. You can actually purge the query data down here. It kind of shows you a pie chart of how much has been used in your query store, what the collection interval is to group things together, how often to flush. I've increased a lot of these just because it's a demo. But the query store now is going to store all that data for me. Before I do that, I want to run the live query statistics. So we looked at displayed execution estimated plan, and we also display the actual plan. There's one here called include live query statistics. So watch this. We include those, run this query, and we get an actual statistics that you see little dotted lines running across. So now you can actually watch this stuff live. If you have SQL Server 2014 SP2 or above with the latest management studio, you can see that in this version. I'm going to show you a really bad one before we continue. I'm joining 2 tables by quantity, and you can just see that little dotted line continuously run. Now, the difference between the plans is here, you're not looking at the cost of the iterator. You're actually looking as a percentage of the estimated number of rows versus the number of rows that have been returned. You can also see clicking off here is the number of seconds that is compiled. And look, even in the properties, these things are moving as we speak. So this is called live query statistics, and it's really cool. I'm going to stop that. I don't see my stop button, but I'm going to stop it anyway. And I'm going to go to that query store. So here, this is some logic that you would alter the database to turn it on. Here's some that would turn it off. I'm going to make sure this index is not on here. This is called a column store index. Again, more of an intermediate level. But what I want to show you is this is actually a select statement from a data warehouse going into a cube. And I'm going to turn on the actual plan, run it again, and you'll see that this plan uses the clustered index. It's not using that non-clustered column store. Let me make sure that that's added. Yeah, it did add it. Oh, you know what? I bet you I have it forced already. Let's go into the query store. So I'm looking at the query store database. Here's all those reports. I'm going to go to top resource consuming queries. Let me hide this stuff so we get a little more room on our machine here. But what you'll see, let me click on that and unforce. It's not letting me take it off. Oh, darn. Let's see. So here in the top consumers, what happened is I've actually forced this query. Let's do this. Let's just remove one column. See if I can get it to just run that. I'm gonna run it. Yeah, that's what happens when you do a live demo, right? Let me get rid of this. Let's just look at this. I'm just going to show you the top consumers. So basically, it's going to show you your plans, and if you have a different plan on the particular query, you can actually see it below. And then you can actually have a button here that compares plans if you have 2 different plans for a particular query. Let me go back to the slide. Sorry that didn't work as well as I thought it was. Thanks. I think we got a series of questions. Again, my name's Thomas LeBlanc. I'm on Twitter at TheSmilingDBA. My website is thomas-leblanc.com, and you can email me at thesmilingdba@gmail.com. I think we're quite out of time, so I'm going to make sure we cover some of these questions in the window. Are you there?
I'm here, Thomas. I'm here.
Hey,
Just wanted to
hey,
thanks for the webinar.
Yeah, sorry, it ran a little bit to the end, but
If you've got the knowledge, we're here to listen, so don't worry about that.
all right, so you want me to go through some of these questions?
Sure, can you see them there, or do you want me to
Yeah,
read them out for you?
yeah, you can read them to me.
All right, I think we'll start from the top. So the first question was, when the clustered index is created, plan uses index scan. It doesn't change the cost compared to table scan. So what is the use of creating one? Is it just to create non-clustered indexes and use them, or something else?
Yeah, so that's a great question. In that case, the clustered index did not help. But what you don't see is a table that has no clustered index, and then you start adding data over time. So we had 1,600 rows in there. Tomorrow there's 3,200. By the end of the month, there's 164,000. Now, that table originally had the clustered index and I dropped it. So it was organized the same. But as you go over time, that cost is going to get greater and greater and greater without the clustered index. I doubt you find anybody that would say don't put a clustered index on a table. The reason I show it in the demonstration is to show you the difference so you understand a table scan versus a clustered index scan and then a non-clustered index scan. So be cautious on creating tables without a clustered index because when you start creating non-clustered and it doesn't have a clustered index, it has to use that row ID to store in the non-clusters, and it could help affect the performance later on. The other thing is a default primary key is usually the clustered index. And if you're in a normalized world or even a dimensional world, you still want a primary key on the table. So thanks for that question, but you should always have clustered indexes.
You had a few scripts with the option recompile, and somebody was asking, what is that?
Yeah, so option recompile basically says don't use the cache plan, recompile it. You'll see a lot of people talk, you'll see blogs and some articles that talk about when to use it and not to use it. Some complicated queries sometimes don't have. It compiles a good plan, then a bunch of data is added, and then SQL Server says, I'm just going to use the compile plan. But when the new data comes in or they update it, a new plan might work better. So that recompile tries to get a new plan for it. Use it with caution. I was using it just to make sure I had the consistent plan for those examples. But some people have to force inside their stored procedures option recompile for complicated queries.
Any good websites or videos for performance tuning and for execution plans?
Yeah, probably if you go through the YouTube of the different virtual chapters of PASS, you'll find plenty of them. I can tell you one thing, and I learned it from what you've seen today. What I learned it from is Redgate has a free execution plans PDF file. A guy named Grant Fritchie, who's the president of the PASS user group now, has written it, and I think he put out a new version of it, and it's really good. And from there, you can go to a lot of places to look at it. But I would start with PASS and the virtual chapters, and I'm sure there's plenty of them out there. The SQLskills.com people do examples of this all the time, so you can get a lot of stuff from it.
Definitely, definitely. And to add that, there is a performance virtual group as well for SQL Pass,
Oh, yeah.
so they'll have stuff.
Yep.
If we have a clustered and a non-clustered index with only duplicates on its key, all rows have the same key value, will this duplicated index rows be always physically sorted in order of clustered index, or will they be ordered arbitrarily? Wow.
Yeah, so that's so what happens is if you have duplicates on the keys, Microsoft or SQL Server puts another row ID on the duplicate value. So if I had state and city and it's repeated and that's the clustered index, it'll have Baton Rouge, Louisiana 1, Baton Rouge, Louisiana 2, Baton Rouge, Louisiana 3. It actually adds an additional ID to it. And that's why people harp on using a surrogate key as a sequential number as the primary key of tables, because it still does that for you, but it eliminates the copying of these duplicate values into the non-clustered index. So it's better to have like a single sequential ID as your clustered index, so it doesn't make the non-clusters really large. But physically sorted, there's not really a physical sort. It almost gets it physically sorted in the data pages, but it doesn't need that because there's a linked list that puts data together inside the data pages. So it could make it a little bit better, but the order would be by the additional ID it puts in for each duplicate row.
And going on from that, there's also a question about somebody having a table with a primary key as a GUID. And is this a good idea to create clustered index on this GUID or choose other columns?
I would choose another column. The GUID is a very sequential value, and if you go look, I don't know if they still have these post up, but Microsoft used that for their sign up for one of the Windows versions. I think it was 8, and the server crashed. It was a big embarrassment for Microsoft. It's not so you can have a GUID as a primary key, but I would suggest making it the non-clustered index and use one or more other columns in the table, hopefully an integer sequential number, as your clustered index. So you can have a primary key that's non-clustered and it could be a GUID, but then you could have another column that's the actual clustered index that's more of a sequential value.
Column store indexes. Somebody would like to know how they show up in the plan.
I almost was able to show one, but it didn't pop up there because of my locked query. But it does show up, and it just says non-clustered column store index. It shows up just like the rest. Now you do have this thing called batch mode and row mode. So there's a couple of different things in the properties that you have to look at. There's a guy named Nico who he's got over 100 blog posts on column store indexes. If you just search, I think NIKO. And column store, he has a whole big series on column store indexes.
I think he's up to like 114 posts now, actually.
Yeah, it's unbelievable. Yeah, he's phenomenal.
Somebody would like you to describe a scenario where it would be preferable to have the index columns included in the B3 instead of just at the leaf level.
Right, so that example I showed of database user with schema and object, someone might search where user is DBO, schema is DBO, and object is table name. So in that case, it's better to have it in the B tree than the leaf level. The leaf level is not searchable, and you'll get that predicate as your search instead of the seek predicate. Good question.
Oh, okay. I actually didn't know that myself. That's really good advice.
Yep.
Would you have any recommendation on where to start learning SQL Server architecture?
Some of the virtual chapters.
Definitely.
Yeah, that's a wide open question, man. If you in a city that has a SQLSaturday, I would go to FreeSQLSaturday. If you got some money in your budget for the company you work for, I would get to SQL Pass, or if you're in Europe, there's the SQL Rallies. There's a couple of SQL conferences, and just go to a bunch of sessions and start asking questions. And there's a lot to learn. SQL Server is not a little easy database anymore. It's very complicated and it's large. And depending on what you're doing at your company, depends on what architecture you want to look at.
Yeah, seconded that. If you can find a SQLSaturday, go for it. If you can find a past chapter, like join them. And if you can't, try and set one up and you'll get help from whatever you can, especially from past itself.
Yeah, that'd be neat. You create your own user group or SQLSaturday and you invite all these people and you learn and put on a free event.
We have someone just asking if you could repeat that answer you gave on the DBO and the schema.
Okay, so let's we can go back to that. I can go back to that. Let's see where I had it. I think it's show plan or table scans and loops. So I believe you can still see my computer, huh?
Yep, still can.
So in here where I'm searching, like here, I'm just saying where database user equals sys. First I got to get into the database. So here I'm just searching on database user, right? But if I wanted to say and schema equals DBO, and object, object equals flag, then now I can use that thing as a seek predicate. And let me turn on my plan. So here it does a seek, and it actually can seek all that data. So my seek predicate here was on all 3 columns. It's not just that one column.
Yeah.
See that? So here, you know, I need it for my seek. But if I didn't have it inside of the clustered index, then it couldn't seek that sort of stuff. It would actually have to do a lookup. It'd have to do a predicate on the include columns, which make the actual thing cost more. I think it's a good explanation. So that if it's in your where or a join, then you actually want it in the B tree part, this part. But if you're just looking for it in your select statement, then you're looking for it to be in one of these covering indexes like this with an include column. Slides in SQL will be shared, right? Yes, it will.
You are like the 5th or 6th person who's asked that, so thank you for answering that one.
Yeah, I see that. Yeah, I can zip up the scripts and send it to y'all and put it on there. It's probably on some other website. All this is done with the AdventureWorks database, so it's nothing new. A lot of them are from that free book too that Regate puts out. So
they actually have a few free books spoken out. I did answer one, but I do want to get your opinion on it. Someone is starting out in SQL Server and wanted to know which one would be the best one to start off on. Just
Which
an
version?
opinion piece. Just which version? Yep.
I would start in the latest. I mean, if you can, go with SQL Server 2017. You know, it all depends. And I mean, if you're just trying to learn, you can download a developer's edition for free, and it has all the functionality of Enterprise.
Exactly. I think that's all the questions that came in, so we are pretty much done. I have a question myself, though, actually.
Sure.
Are you running a case-sensitive instance?
No.
Okay.
No, it should be case insensitive.
I was just thinking that when you have every case the same and you were fixing them up, I was like, you're not that
No.
statistic to yourself, are you? No.
No. We do have some case sensitive where I work, but not here.
Lovely, and that is it. If you, we have a question about the Redgate book. If you just go onto Redgate's website, they have multiple books as downloads, so check them out there.
Yeah, just search Redgate Grant Fritchie.
I'm not sure if Steve is there, so I will take it upon myself to thank you once again, Thomas.
No problem, man. Thanks, Shane.
Really educational. It's always great when I come to these things and learn things myself, so thank you very much.
Wonderful. It's a great session to do. I think a lot of people like this session. I've done it at so many, a bunch of SQL Saturdays now. So it's been nice. And I'm going to do it at VS Live in Austin, March 2nd of this, or March 1st of this year.
Well, best of luck. I think the only thing is if you get that query store not stuck on forced, you'll be 100%.
Yeah, that was not, I wasn't planning on that one not working, so that disappointed me. I'm not sure why it wouldn't let me unforce it. Yeah, I don't know why it's stuck. Yeah. Usually I show the example of forcing the plan and then unforcing it and showing the column store index. But for some reason it's stuck, man. Oh, there it goes. Oh. Oh man. So I just need to do a couple more things. Oh man. Let's see. Here's that query. Let's see if I can run it and then get rid of the top consumer. Go back to, top consumer. Yep, there it is. So here's your 2 plans. So here's the one with the column store the guy was asking about. Let's see if the guy's still online. Oh man.
I don't think he is,
Yeah.
but he also asked.
There's your column store, and that's this plan down here. But this plan up here, if you watch the bottom, when I click on it, it goes to the clustered. So now you can actually highlight one, shift on the other, control or shift, click on the other, click compare plans, and it'll bring the two plans side by side. So the column store keeps all your execution plans over time, and if one changes, like with that option recompile, you can actually look at an old one and a new one and compare them to see what's different. Really neat stuff in the query store. I'm sure someone's doing a query store session on y'all's virtual chapter. I'm guarantee you somebody is.
We had one from Aaron's the last day, and every time I see it, I keep meaning to introduce it, and I haven't.
Yeah, it's a great thing right now. People are all over it. That just shows you the progression of how great Microsoft has been to the SQL Server world.
We did have a question as well, if you want to show that batch mode you mentioned as well about the column store.
Yeah, so let's see if it shows. So let's see. Yeah, execution is batch. See, execution mode is batch. Batch, from what I read from Nico, this is the better mode to run in. But if you ever see row in here, something needs to be tweaked with your column store index. So it's your actual execution mode is batch, not row.
Perfect. That's pretty much it. To the people asking if recordings will be posted, we will get on that straight away after this. Thank you all for sticking around. We hope you learned a lot. We have coming up Kendra Little, Rob Farley, Charles Kim talking about index design, advanced indexing, and Linux fundamentals. Thank you for sticking around, and we will try and get everything out to you as soon as you can. Thomas, thank you so much again.
Thank you, Shane. You did a great job, buddy.
Thanks,
Thank
Thomas.
you.
Thanks.
Thanks, Steve.
Bye.
Bye.